Imagine a security system so intensely focused on a single past break-in that it permanently redirects all its processing power away from monitoring reality and toward running a non-stop high-voltage threat simulation. Popular culture frequently mischaracterizes trauma as a psychological scar, a collection of painful memories, or an inability to let go of the past. But structural neuroscience has exposed a far colder reality. Trauma is a radical physical reallocation of your brain's biological hardware. When the nervous system is subjected to an overwhelming life-threatening event, it initiates a survival-driven emergency protocol that rewrites your genetic and structural code. The brain effectively decides that the luxury of higher cognitive processing, creative intelligence, and emotional presence must be sacrificed to ensure immediate physical survival. This is the origin of the shattered filter, a state where the brain's sensory gateways collapse, leaving the conscious mind completely flooded by the raw, unfiltered chaos of the external environment. It is not an emotional weakness. It is a profound anatomical adaptation where your nervous system has structurally traded its capacity for peace in exchange for absolute hypervigilant survival efficiency. To understand how this filter collapses, we must map the fundamental processing plant for all human experience, the thalamus. Nestled deep within the center of the brain, the thalamus acts as the master gateway for consciousness. Every single sight, sound, touch, and physical sensation entering your body, with the sole exception of smell, must travel down your sensory nerves and pass through the thalamus before it can be pushed to your higher cerebral cortex for conscious awareness. This massive influx of raw data is regulated by a thin, dense sheet of inhibitory neurons wrapping around the thalamus called the Thalamic Reticular Nucleus, or TRN. The TRN acts as your brain's ultimate data editor. It uses GABAergic signaling to suppress up to 99% of background noise, the hum of a refrigerator, the texture of your clothes or the passing traffic, so your higher brain can focus on what is meaningful. But when trauma rewires the nervous system, the TRN suffers a critical, localized metabolic failure. The biological editor goes completely offline, rendering the brain structurally incapable of filtering out the baseline background static of the world. The failure of the thalamic gatekeeper is driven by a profound loss of top-down inhibition from the brain's ultimate executive manager, the ventromedial prefrontal cortex, or VMPFC. Located right behind the center of your forehead, the VMPFC behaves like a biological shield. It is responsible for assessing context and issuing calm, regulatory commands to your lower emotional centers. In a healthy brain, if a sudden loud noise occurs, your sensory organs relay the signal to the thalamus, which passes it to the cortex. The VMPFC rapidly analyzes the environment, concludes that the noise was just a car backfiring, and sends strong, down-regulating signals to silence your survival alarms. This is known as successful top-down control. But in a brain rewired by severe trauma, chronic stress hormones cause a physical erosion of the long, projecting glutamatergic pathways that connect the VMPFC to the lower brain. The shield is shattered. The VMPFC enters a permanent state of hypoactivity, completely losing its structural ability to issue regulatory commands, leaving the lower survival circuits to operate with total, unchecked autonomy. With the top-down inhibition of the prefrontal shield disabled, an ancient subcortical structure enters a state of permanent, high-voltage hyperreactivity, the amygdala. Tucked deep within the temporal lobes, the amygdala acts as the brain's centralized threat detector and emotional alarm system. It is a highly aggressive cluster of neurons designed to instantly trigger the body's fight-or-flight response the moment it perceives danger. Under normal conditions, the amygdala fires sharply and then quietens down once the threat is passed. But in the aftermath of trauma, the lack of prefrontal veto power, combined with structural changes in the amygdala's basolateral nucleus, locks this alarm system into a permanent on position. The amygdala becomes like a home alarm whose sensor has rusted at maximum sensitivity. It no longer requires a genuine threat to activate. It fires continuously in response to completely neutral environmental cues, a specific tone of voice, a crowded room, or a sudden movement. The brain is subjected to a constant internal chemical siren that keeps your body flooded with adrenaline, regardless of objective reality. The combination of a broken thalamic gatekeeper and a hyperreactive amygdala triggers a catastrophic phenomenon known as sensory flooding. Because the thalamic reticular nucleus can no longer gate incoming signals, and the amygdala is screaming that danger is imminent, the thalamus opens its floodgates wide. It forces an uncoordinated, high-volume cascade of raw sensory data straight up to your primary sensory cortices. This is the neurobiology of overwhelm. The brain is hit by a massive wave of unfiltered electrical noise. Sights appear blindingly sharp, sounds feel piercingly loud, and physical environments register as chaotic and unpredictable. The conscious cortex is completely outpaced by the sheer volume of data it is forced to compute. This state of thalamocortical dysrhythmia shatters your ability to maintain selective attention. You cannot isolate a single conversation or focus on a single task, because your brain is treating every single background stimulus in the room as a highly urgent, potentially life-threatening survival cue that demands immediate metabolic attention. This sensory chaos directly disrupts one of the most vital memory management structures in the human brain, the hippocampus. Located adjacent to the amygdala, the hippocampus acts as your mind's internal timestamper and filing cabinet. Its primary job is to take raw, chaotic experiences from your sensory cortices, organize them into a linear timeline, assign them a specific date and time, and file them away as past events. This is what allows you to look back at a difficult memory and say, "That was bad, but it is over now." But when the amygdala fires at maximum voltage, the extreme surge of stress hormones, specifically cortisol and norepinephrine, systematically paralyzes the hippocampus. The timestamper is completely knocked offline. The brain loses its structural ability to assign a chronological stamp to the traumatic experience. Instead of being neatly filed away in the past, the raw sensory components of the event remain floating in a state of suspension, entirely uncontextualized by time, leaving the brain permanently confused about whether the danger is over or still happening right now. Because the hippocampus fails to timestamp and integrate the experience, the brain is forced to store the trauma as a collection of fragmented sensory shards. When you experience a normal event, your brain synthesizes a cohesive narrative, a story with a beginning, middle, and end. But under the influence of hippocampal paralysis, this synthesis mechanism completely collapses. The event is broken down into its raw chemical elements, a specific scent, a sharp visual pattern, a particular pitch of sound, or an internal feeling of muscle tension. These fragments are scattered randomly across your primary sensory cortices. This is the neurobiology of the deconstructed present. The individual does not possess a clean, linear memory of what happened. They possess a minefield of unintegrated sensory triggers. The brain is left in a state of high structural vulnerability, where any mundane environmental input that matches one of these floating shards can instantly trip the hypersensitive amygdala alarm without warning. This sensory fragmentation gives rise to one of the most agonizing phenomena in all of psychology, the intrusive flashback loop. When an individual in recovery encounters an environmental trigger, even a completely harmless one that matches a single sensory shard of the past, the hyperreactive amygdala fires instantaneously. Because the prefrontal cortex is hypoactive and cannot offer context, and the hippocampus has failed to label the memory as past, the brain executes a total computational error. It retrieves the scattered sensory fragments from the cortices and projects them into your current conscious awareness as a live feed. This is not an act of remembering. It is a literal re-experiencing. The brain's predictive coding engines completely override the actual physical present. Your pupils dilate, Your heart rate spikes to survival maximums, and your mind is biologically convinced that the past event is actively occurring in the room. The individual is trapped inside an intrusive loop, where their own neurological processing error forces them to physically endure their worst moments over and over again. Living inside this intrusive sensory loop inflicts an immense, unsustainable metabolic drain on the entire human system. The continuous activation of the amygdala and the constant flooding of the thalamocortical pathways require an enormous expenditure of the brain's base energy budget. To maintain this state of perpetual high alert, your nervous system is forced to redirect glucose, oxygen, and ATP away from your higher-order cognitive processing and long-term biological maintenance networks. This is the neurobiology of hypervigilance. Your prefrontal cortex is essentially starved of its primary fuel sources to keep your subcortical survival engines running at maximum capacity. This permanent power drain leaves the individual in a state of chronic, unprovoked cognitive exhaustion. Your working memory shrinks, your verbal processing speed slow to a crawl, and your ability to engage in complex, abstract problem-solving is severely compromised, completely drained by a system that is burning its fuel at maximum capacity just to scan the room for non-existent threats. If the brain remains trapped in this hypervigilant metabolic drain for too long, the dark side of neuroplasticity steps in to make the survival state permanent through structural atrophy. The continuous, high-dose exposure to circulating glucocorticoids and inflammatory cytokines acts as a toxic compound within your higher brain regions. Neuroimaging studies consistently reveal a devastating anatomical truth in individuals with long-term unintegrated trauma: a significant, measurable reduction in the volume of both the hippocampus and the prefrontal cortex. The delicate dendrites and synaptic connections within these regions physically wither away from lack of energy and chronic chemical toxicity. The tissue behind your forehead and within your memory hubs becomes noticeably thinner and less dense. This is not a temporary functional slowdown. It is a permanent structural restructuring. The brain is physically dismantling the very hardware required to generate emotional regulation and chronological memory, locking the individual into an increasingly rigid biological cage where survival is the only operational setting. The discovery of this profound structural decay exposes the complete fallacy of traditional, purely cognitive approaches to trauma resolution. We live in a culture that continuously tells individuals to just talk through it, change your mindset, or use logic to get over the past. But the rigid architecture of neuroscience completely obliterates these simplistic demands. You cannot talk a hypoactive prefrontal cortex into regrowing its lost gray matter volume overnight. You cannot use pure logic to command a paralyzed hippocampus to suddenly timestamp a floating sensory fragment. And you cannot use a motivational quote to silence a hyperreactive amygdala that is firing entirely beneath the level of conscious cognitive awareness. Trauma is not a problem of the rational mind. It is a physical structural reorganization of the subcortical hardware. Expecting a person to simply think their way out of a shattered thalamic filter is a biological impossibility, because the very tool required to execute that rational control has been systematically disassembled by the survival response. We have now mapped the complete, devastating anatomy of the shattered filter, revealing trauma not as an emotional state, but as a systemic hardware failure across the entire brain. The loop is absolute. The failure of the ventromedial prefrontal cortex leaves the brain without its top-down regulatory shield, releasing the ancient amygdala to fire its alarm sirens relentlessly. This chronic panic disables the thalamic reticular nucleus, causing the primary thalamic gateway to collapse and flood your sensory cortices with an uncoordinated, overwhelming stream of raw environmental static. Simultaneously, the hippocampus is paralyzed, leaving the experience to be stored as a collection of fragmented, timeless sensory shards that trigger intrusive flashbacks and drive a massive, unsustainable metabolic drain that physically shrinks your higher brain tissue. This is the structural architecture of a mind trapped in a permanent emergency protocol. Understanding this neurobiology is the ultimate point of leverage, because it shifts the conversation entirely away from moral expectation and firmly into the realm of physical network restoration, providing the essential foundation upon which all real biological recovery must be built. Now that we have uncovered how an overwhelming survival response physically collapses the brain's primary sensory gatekeeper and paralyzes its time-stamping hardware, we must examine the internal war that breaks out inside the body as a direct result. In our next section, we will climb out of the sensory cortices and journey directly into the deep interoceptive networks, examining the neurobiology of the rusted compass to see exactly how a hyperactivated insular cortex transforms your own internal organs into a source of continuous physical terror. The most terrifying aspect of a survival-driven hardware reallocation is not how it alters your view of the external world, but how it turns your own body into an inescapable source of threat. While the first phase of our deep dive exposed how trauma shatters your external sensory filters, this second phase uncovers a far more intimate civil war. Your brain is not just a device that looks outward through your eyes and ears. It is a master monitor that constantly reads the microscopic ecosystem of your internal organs. When the nervous system is trapped in a permanent emergency protocol, this internal monitoring loop suffers a catastrophic distortion. This is the origin of the interoceptive war. It is a state where your brain completely loses the ability to calculate internal safety, transforming your heart rate, your breathing, and your digestive tract into a collection of biological weapons. You are no longer just unsafe in your environment. You are physically unsafe inside your own skin, locked in a continuous loop of visceral panic manufactured by a broken internal compass. To understand how your internal landscape becomes weaponized, we must map the fundamental hardware of self-sensing, the insular cortex. Tucked deep within the lateral sulcus of the brain, the insula acts as the master landing pad and processing hub for all interoceptive data. Every second, millions of electrical signals travel up your vagus nerve and spinothalamic tracts, feeding the insula a live data stream of your internal reality. It tracks the chemical composition of your blood, the stretching of your stomach walls, the tension in your muscles, and the rhythm of your heart. In a healthy nervous system, the insula processes this data cleanly, assigning an accurate emotional and physical context to your state. It is the literal biological substrate of your gut feelings. But when trauma disrupts the brain's baseline, the insular cortex undergoes a profound structural calibration error. The internal compass becomes rusted. It loses its resolution, rendering it completely incapable of distinguishing between a normal, healthy physical shift and a catastrophic, life-threatening survival emergency. This calibration error completely paralyzes the brain's primary bodily regulation network, the interoceptive prediction engine. Just as your cortex uses predictive coding to map the external world, your insula uses it to map your internal state. It generates constant, top-down predictions of what your organs should feel like, comparing them against the actual bottom-up sensory data arriving from your body. Under normal conditions, minor variations are easily filtered out, but in a traumatized brain, the hyperreactive amygdala forces the insula to generate highly distorted, threat-biased top-down predictions. The brain expects the body to be in a state of violent physical exertion or trauma at all times. When a perfectly normal bodily shift occurs, such as a slight increase in heart rate from climbing stairs, or a change in digestion from a meal, the insula interprets this variation as a massive, life-threatening prediction error. It concludes that your heart is failing, or your system is under immediate attack, generating an intense, unprovoked surge of psychological terror in response to your own normal physiology. This internal prediction error is immediately funneled into a highly aggressive neighboring structure, the dorsal anterior cingulate cortex, or DAC. The DAC acts as the brain's internal amplifier and distress coordinator. Its job is to take the threat signals generated by the insula and translate them into coordinated behavioral and autonomic corrections. In a healthy state, it keeps your bodily responses perfectly proportional to your environment. But in the grip of the interoceptive war, the DAC behaves like a faulty volume knob stuck at maximum capacity. It takes the minor prediction errors arriving from your insula and subjects them to massive visceral amplification. It fires frantic, down-regulating signals straight to your sympathetic nervous system, ordering your heart to beat even faster, your lungs to constrict, and your adrenal glands to dump massive quantities of cortisol into your bloodstream. This creates an immediate, self-reinforcing loop. The brain's distorted perception of the body forces the body to enter a genuine state of physical panic, which then loops back to confirm the brain's original delusion. This frantic signaling from the DACs shatters the delicate equilibrium of your autonomic nervous system, forcing a profound biological event known as the polyvagal split. Your autonomic nervous system relies on a beautiful balance between the sympathetic branch, which accelerates your body for action, and the parasympathetic branch, which slows it down for rest and digestion. In a brain rewired by trauma, this balanced seesaw is completely destroyed. The sympathetic nervous system is kept under continuous maximum stimulation, keeping your body's accelerator pushed to the floorboards. To prevent your cardiovascular system from collapsing under this relentless pressure, the brainstem deploys a primitive emergency braking system mediated by the unmyelinated dorsal motor nucleus of the vagus nerve. This is the neurobiology of the freeze response. The accelerator and the brake are pushed down at the exact same time. Your body is caught in a state of high-velocity internal friction, trapped in a physiological gridlock where you feel simultaneously hyper-agitated and completely paralyzed. As the autonomic seesaw collapses, the structural degradation spreads into the primary mapping zones of your higher cortex, the somatosensory network. Spanning the postcentral gyrus, this network contains a highly detailed, topographically organized map of your entire physical body, often referred to by neurobiologists as the cortical homunculus. Every square inch of your skin and every muscle group has a dedicated folder of neurons in this map. In a healthy individual, this somatosensory map allows you to feel precisely grounded in your physical frame. But under the continuous bombardment of amplified visceral distress and conflicting polyvagal signals, the somatosensory network suffers a total computational breakdown. The map becomes completely blurred and pixelated. The brain loses its capacity to maintain an accurate, high-resolution readout of its own physical boundaries. This is the neurobiology of the ghost body, a state of profound physical dissociation where the individual feels entirely disconnected from their limbs, as if they are floating outside their own flesh, viewing their physical form as a foreign object. This physical dissociation directly corrupts the resting architecture of the higher brain, completely transforming the behavior of the default mode network, or DMN. As we established in our previous deep dives, the DMN is the neural substrate that builds your personal narrative, your biographical memories, and your sense of self-identity. It is tightly wired into the insular cortex, using interoceptive data as the foundational anchor to construct a continuous, stable sense of me. But when the insula is blinded by calibration errors and the somatosensory map is blurred, the DMN loses its biological anchor. The sense of self becomes completely ungrounded. The narrative generation engine of the DMN spins out of control, no longer anchored by the reality of a safe, stable body. It begins to construct an identity built entirely around vulnerability, fragmentation, and continuous threat. The individual's internal monologue becomes highly distorted, processing every passing thought through a lens of deep alienation, physically unable to generate a narrative of safety because the biological foundation of that safety has been erased. The ungrounded processing of the DMN, combined with chronic visceral amplification, forces the nervous system to enter a state of severe clinical somatization. Somatization is the process where deep, unintegrated psychological trauma is physically translated into chronic structural bodily illness. Because the brain's frontoparietal control pathways are decoupled and cannot process the trauma through higher-order abstract reasoning, the lower subcortical networks are forced to express the distress through your physical organs. This is not an imaginary condition, it is a profound biological reality. The continuous leaking of pro-inflammatory cytokines and stress hormones from your dysregulated autonomic axis alters the physical tissue of your body. It degrades your gut microbiome, leads to chronic muscle tension, compromises your immune system, and triggers widespread inflammatory pain pathways. The body becomes a living, breathing canvas for the unexpressed survival response, physically executing the trauma through structural illness because the higher brain networks have lost the capacity to process it cognitively. The internal war launches a direct, localized assault on the primary command center for human language, Broca's area. Located in the left inferior frontal gyrus, Broca's area is the executive processing plant responsible for translating internal thoughts, concepts, and emotions into spoken words. Functional neuroimaging studies of traumatized individuals encountering a trigger reveal a startling, repeatable phenomenon. While the emotional subcortical centers and the right hemisphere light up in a violent storm of activity, Broca's area goes completely dark. This is the neurobiology of speechless terror. When the interoceptive war reaches maximum velocity, the massive influx of adrenaline and visceral distress actively shuts down the speech centers of the higher brain. The individual is left structurally incapable of putting their experience into words. They can feel the crushing weight of the trauma in their chest and stomach, but the higher-order neural networks required to articulate, label, and share the distress are physically offline, trapping them in a silent, isolated cage of raw physiological sensation. The silencing of the speech centers, combined with the calibration failure of the insula, gives rise to a profound psychological deficit known as alexithymia. Alexithymia is the absolute inability to identify, name, or describe your own emotional states. An individual suffering from trauma-induced alexithymia does not possess the neurological resolution required to say, "I'm feeling angry," "I'm feeling sad," or "I'm feeling anxious." Instead, when their hyperreactive survival circuits fire, they experience it purely as a massive, undifferentiated wave of physical distress. They feel a tightening in their throat, a burning in their stomach, or a sudden weakness in their limbs, but they are completely blind to the emotional meaning behind these sensations. Their introspective resolution has been entirely flatlined. The brain looks inward at its own internal landscape and sees only an incomprehensible, terrifying storm of raw biology, entirely stripped of the emotional vocabulary required to understand or regulate the self. This total loss of introspective resolution traps the individual inside a dangerous psychological illusion regarding the true source of their distress, the illusion of environmental triggers. Because the traumatized brain can no longer accurately read its internal landscape, and because it is locked in a state of high tonic autonomic panic, it constantly misattributes the source of its discomfort. When the insula and area 25 generate a wave of visceral pain or muscle tension out of nowhere, the predictive coding engine looks outward to find a logical explanation. It searches your immediate environment and aggressively highlights completely innocent external targets. It tells you, you feel terrible because that person looked at you weird, you are panicking because this room is too small, or you are angry because of the weather. The conscious mind genuinely believes these illusions. The individual becomes hyper-focused on controlling and manipulating their external environment to find safety, entirely unaware that the true enemy is not outside them, but is a continuous, automated stream of distorted internal telemetry generated by their own broken nervous system. We have now mapped the complete, inescapable matrix of the interoceptive war, revealing how trauma completely subverts the internal safety mechanisms of the human body. The loop is absolute and terrifying. The structural calibration failure of the insular cortex shatters your internal prediction models, causing normal bodily shifts to register as catastrophic life-or-death emergencies. This prediction error is amplified by the DAC, which floods your autonomic nervous system with uncoordinated commands, driving your body into a violent polyvagal split where the accelerator and brakes are slammed simultaneously. This continuous distress blurs your somatosensory map, erasing your physical boundaries and allowing the default mode network to construct a narrative built entirely around alienation and vulnerability. Finally, Broca's area is silenced, and alexithymia locks in, leaving the individual structurally incapable of articulating their agony, forced to live inside a ghost body that continuously misattributes its internal panic to the external world. Breaking this matrix is not a matter of cognitive reframing. It requires a radical somatosensory intervention that directly repairs the internal telemetry, forcing the rusted compass to finally recalibrate and return to reality. Now that we have witnessed how the interoceptive war transforms your own internal organs into an inescapable battlefield of visceral panic, silencing your speech centers and blurring your physical boundaries, we must descend to the absolute final layer of this biological trap. In our next and final installment, we will journey down to the very nucleus of the cell to witness the epigenetic freeze, examining how severe trauma alters your DNA expression to lock your stress axis into a permanent state of high-alert cellular bankruptcy. Imagine an emergency broadcast system that becomes so overwhelmed by a single catastrophic transmission that it permanently splices that alarm signal directly into the station's core programming hardware. Throughout our exploration of the trauma architecture, we have watched the higher filters collapse and the physical organs descend into a state of visceral warfare. Now, we arrive at the absolute flaw of the biological trap. The final, most terrifying adaptation of a survival-oriented brain does not occur across large-scale neural networks or visceral organs. It takes place deep inside the microscopic nucleus of your individual cells. When the nervous system encounters a threshold of existential terror, it executes a profound shift from a temporary electrical response to a permanent molecular restructuring. This is the origin of the epigenetic freeze, a state where the brain permanently alters how your DNA is read, locking your primary stress machinery into a permanent state of high-alert cellular bankruptcy. It is an anatomical truth that completely redefines our understanding of human suffering. Trauma does not just change how you think, it rewrites the physical genetic expression of who you are. To understand how this genetic lock closes, we must examine the master neuroendocrine engine of the human body, the hypothalamic pituitary adrenal axis, or HPA axis. The HPA axis is a highly coordinated, multi-tiered chemical highway designed to manage your body's survival responses to extreme stress. The loop begins in the paraventricular nucleus of the hypothalamus, which responds to perceived danger by secreting corticotropin-releasing factor, or CRF. This chemical messenger travels down a specialized capillary network straight to the pituitary gland, forcing it to release adrenocorticotropic hormone, or ACF, into your systemic bloodstream. The ACTH floats down to your kidneys, binding to the adrenal cortex and ordering the immediate massive release of glucocorticoids, primarily cortisol alongside adrenaline. In a healthy organism, this chemical cascade is a magnificent life-saving resource. It mobilizes your glucose reserves, accelerates your heart rate, and sharpens your immediate focus, providing the raw physical power required to fight or flee an immediate, real-world predator. Under normal evolutionary conditions, this massive hormonal surge is strictly temporary, regulated by a beautifully engineered biological thermostat known as the negative feedback loop. When cortisol levels spike in the bloodstream, the molecules float back up into the brain, crossing the blood-brain barrier and binding to highly dense clusters of glucocorticoid receptors located within the hippocampus and the hypothalamus itself. This binding acts as a definitive biological off switch. The moment these receptors are saturated with cortisol, they send immediate high-velocity inhibitory signals down to the hypothalamus, telling it to instantly stop production of CRF. The chemical alarm is silenced, and the body safely returns to its homeostatic baseline. But in a brain rewired by severe trauma, this master thermostat suffers a catastrophic structural failure. The glucocorticoid receptors within the hippocampus become profoundly desensitized and downregulated. The brain loses its physical capacity to detect its own stress hormones. The off switch is broken, leaving the HPA axis to operate as an uninhibited runaway engine that continuously floods your system with stress telemetry. The permanent desensitization of this stress thermostat is driven by a profound epigenetic alteration within the DNA of your reward and memory neurons, specifically targeting the NR3 cone gene. The NR3 cone gene is the exact architectural blueprint your cells use to manufacture glucocorticoid receptors. Under chronic, overwhelming stress, the cell nucleus initiates an aggressive defense mechanism called DNA hypermethylation. Specialized enzymes called DNA methyltransferases travel along your genetic strands, physically attaching dense clusters of carbon and hydrogen atoms, known as methyl groups, directly to the promoter region of the NR3 cone gene. Think of it like pouring heavy industrial concrete over a critical blueprint in a library. Because the gene is heavily methylated, the cell's transcription machinery can no longer read the code. The manufacturing of glucocorticoid receptors drops to a historic deficit. The cell is epigenetically locked in a state of receptor scarcity, meaning that no matter how much cortisol is circulating in your body, your brain remains completely blind to it, unable to deploy the negative feedback brakes. This epigenetic locking mechanism is further reinforced by a secondary genetic distortion involving a specialized chaperone protein encoded by the FKBP5 gene. Under normal conditions, the FKBP5 protein acts as a temporary intracellular brake that prevents glucocorticoid receptors from binding to cortisol too quickly, ensuring your stress response doesn't overreact to minor daily annoyances. But when severe trauma floods the system with a toxic concentration of stress hormones, it triggers an abnormal, permanent upregulation of FKBP5 expression. The chaperone protein accumulates inside the cell at a pathological density. It physically binds to the remaining non-methylated glucocorticoid receptors, locking them in a low-affinity state where they are structurally unable to grab passing cortisol molecules. This is the molecular tipping point of the epigenetic freeze. The brain's internal stress brakes have failed at two independent cellular levels. The NR3 cone gene cannot build the receptors, and the hyperactive FKBP5 gene ensures that the few receptors that do exist are completely paralyzed, trapping your nervous system in a state of permanent chemical alert. The complete collapse of the HPA axis negative feedback loop drops the body into an exceptionally destructive physiological state known as chronic allostatic load. Allostasis is the process by which the body actively adapts to adverse conditions to maintain stability, but when the chemical brakes are failed, the price of that adaptation becomes entirely unsustainable, because the hypothalamus is continuously screaming for more survival resources. Your blood is permanently saturated with a highly toxic cocktail of cortisol, adrenaline, and glucose. This chronic chemical saturation inflicts severe, widespread damage across your entire biological infrastructure. It raises your systemic blood pressure, degrades your vascular lining, causes severe insulin resistance, and systematically dismantles your metabolic efficiency. The body is no longer adapting to stress. It is being slowly, physically consumed by its own survival machinery. The individual is left trapped inside a biological vehicle that is running its engine at maximum RPMs every single second of the day, rapidly wearing out its internal components while parked in a completely safe room. The continuous high-dose exposure to circulating cortisol inflicts its most severe immediate damage on the delicate neurons of your primary memory hub, the hippocampus. While cortisol provides energy to your muscles, it acts as a highly potent neurotoxin when left unregulated within the brain's gray matter. Prolonged cortisol saturation disrupts the primary glutamate transporters within your hippocampal synapses, causing a permanent accumulation of excess glutamate in the synaptic cleft. This leads to a catastrophic phenomenon known as excitotoxicity. The postsynaptic neurons are continuously bombarded by excitatory signals, forcing an unnatural influx of calcium ions into the cell. This calcium overload triggers internal enzymatic cascades that physically digest the cell's internal architecture from the inside out. The delicate dendrites wither away, the synaptic connections snap, and the birth of new neurons, a process called neurogenesis, comes to a complete halt. Your brain's primary timestamper and filing cabinet is physically eroded at the cellular level, leaving you with a structurally shrunken hippocampus that cannot process the past or ground you in the present. While the prefrontal cortex and the hippocampus are experiencing severe structural erosion and cellular death under allostatic load, an adjacent structure undergoes a terrifying, paradoxical expansion, the basolateral amygdala. Unlike the higher cognitive centers, the neurons within the amygdala respond to chronic cortisol saturation by rapidly growing new, highly complex dendritic branches, a phenomenon known to neurobiologists as dendritic hypertrophy. The amygdala is quite literally feeding on your stress hormones. It behaves like a cancer within your motivational hardware, using the body's emergency energy reserves to expand its physical infrastructure. The density of its synaptic connections multiplies exponentially. This structural hypertrophy transforms the amygdala into a massive, high-speed electrical generator that dominates the entire landscape of your brain. The baseline threshold required to trigger a survival response drops to near zero. Your ancient threat detection machinery is no longer just hyperreactive, it has physically outgrown the higher-order networks designed to regulate it, structurally locking your consciousness into a permanent state of predatory vigilance. This structural distortion triggers a severe immune reaction within the brain itself, introducing the final toxic element of chronic neuroinflammation. The continuous excitotoxicity and network friction alert the brain's resident immune cells, the microglia. As we established in our study of overconsumption, when microglia sense prolonged cellular distress, they toggle into an aggressive, pro-inflammatory posture. In a traumatized brain, this activation is amplified by a complete compromise of the blood-brain barrier. The chronic high blood pressure and circulating stress hormones degrade the tight junctions of the endothelial cells that protect your cerebral tissue. The gate is broken. Pro-inflammatory cytokines and peripheral immune cells from the body flood into the central nervous system, completely unfiltered. This neuroinflammatory storm breaks down the basic chemical balance required for clean neural communication. The higher prefrontal networks are cast into a permanent state of metabolic sickness, completely smothering your working memory and rendering cognitive clarity an absolute physical impossibility. The molecular and structural decay eventually completely exhausts the body's primary network for peace and restoration, the parasympathetic nervous system mediated by the vagus nerve. In a healthy individual, high vagal tone acts as a powerful biological brake that suppresses inflammation, slows down the heart, and promotes deep cellular repair. But the continuous, unchecked firing of the hypertrophied amygdala keeps the sympathetic nervous system pushed to its absolute threshold, completely overwhelming the vagal brakes. Over time, the vagal tone is entirely depleted. The body loses its physical capacity to generate a relaxation response. Your heart rate variability flatlines, your digestive enzymes stop secreting, and your immune system loses its primary anti-inflammatory signal. You enter a state of systemic autonomic exhaustion. The individual is left entirely unprotected against their own internal stress chemistry, unable to sleep deeply, unable to digest food efficiently, and unable to find a moment of physiological rest, completely bankrupted by a nervous system that has spent all its biological reserves on survival. The revelation of this deep molecular, genetic, and structural architecture exposes the absolute fallacy of the popular cultural demand for sudden trauma healing. We are continuously bombarded with superficial self-help narratives that promise to instantly heal your past through single breakthrough moments, motivational epiphanies, or rapid mindset shifts. The rigid reality of structural neuroscience completely obliterates these claims. You cannot think your way out of an NR3 cone gene hypermethylation. You cannot use pure willpower to instantly degrade accumulated FKBP5 proteins that are physically bound to your DNA. You cannot use a positive affirmation to force your shrunken hippocampus to instantly regrow its lost neurons, or command your hypertrophied amygdala to physically shrink its dendritic superhighways overnight. Trauma is a systemic, genetic, and structural lock that has rewritten your entire biology. Treating this profound cellular reality with superficial lifestyle hacks is a biological insult that only deepens the cycle of shame, trapping the individual in a loop of failure simply because they are using tools that cannot reach the depth of the wound. How then does a human being ever escape this epigenetic cage? The answer lies in accepting that just as the dark side of neuroplasticity built the prison, a slow, highly calculated path of molecular reversion can dismantle it. Because epigenetic modifications are stabilized by physical-chemical bonds, they require a prolonged, highly structured environment of absolute predictable safety to naturally unwind. This is not a psychological timeline of weeks. It is a biological timeline of many months of continuous, somatic, and physiological stabilization. As the brainstem is consistently fed signals of authentic, bottom-up safety, the paraventricular nucleus slowly downregulates its CRF production. This allows the DNA methyltransferases to naturally recede, slowly unwinding the methyl groups from the promoter region of the NR3 cone gene and allowing the cell to finally rebuild its lost glucocorticoid receptors. The amygdala slowly prunes back its hypertrophied dendritic superhighways. The hippocampus restarts neurogenesis, and the vagal tone is gradually restored. The baseline of the brain slowly returns to zero. This is a physical, anatomical resurrection that mirrors the slow growth of a forest after a fire. It cannot be short-circuited. By understanding the rigorous neuroscience of this path, we finally see trauma for what it truly is, a profound structural challenge that requires a precise biological timeline to heal. If you prefer objective, data-driven neuroscience explanations over superficial self-help hacks, you have found your community. Subscribe to keep building your neurological literacy. This is Archive of Becoming, and I will see you in the next deep dive.